Hi everyone, welcome to today's webinar on access and haul road design, plus a little bit of earthwork optimization. So if you don't know me, I'm Erin, I'm the Business Development Manager here at Softree. And today I have the pleasure again of hosting our webinar. We're gonna get off to actually a really fast start here in the software. I'm going to save most of my introduction actually for a few minutes from now once we've got an optimization running. But our plan for today at the highest of levels is we're going to show you two different projects. We're going to start off doing an access road project, which I'm going to pass the screen pretty much immediately here to Matt to get started with, to get that optimization running. And then we're going to follow it up by a significantly more complicated in-pit haul road, featuring some really cool benching and stuff. So with that, I'm not spending any time on the intro right off the bat. I'm going to pass the screen over to Matt. And we're going to get started pretty much right away on that access road, showing you, some of the new optimization tools. And then I'll take it back and give you a little bit more of an insight into where we're going with the rest of the webinar.
Perfect. All right, I will dive right into it. I'll talk my way through, but Erin will certainly elaborate on the steps as once we go back after things are running in the background. So I'm starting my project out in terrain. We're going to start by bringing in our survey data. So this first example that we're going to do is the access road. So I'm going to click Insert File. I'm going to bring in my surface data. So I've got a LiDAR data for this one. We've got our projection getting assigned. And so bringing in that DEM data, software is building the tin right now. And so I'm going to just click off to the side here, open up my 3D window, and I can see, okay, we've got a surface to work with. Now, a few kind of optional steps. One, I'd like to see some contours, so I'm going to generate my contours. I'll go with the 120 meter intervals. And just while that thinks, so we've got about 500,000 points in our model points. And for this, I'd like to have some idea where my streams likely are as we plan and go forward here. So I'm going to go into streams and ponds. And we'll run this. So this tool is just using a minimum flow accumulation value and generating streams from that based off of a raster model. So we've got our streams, and next we're going to bring in kind of where we'd like to start and where we'd like to end. So I'm going to bring in, that's just a shape file here to so I want to start here. I want to go up to there. Rather than going the traditional approach and clicking around and or going out to the woods and walking the hillside and figuring out how we want to get to here, from here, we're going to use our new tool. So I'm going to tell it I want 3 options. I'm going to set my max grade at 15%. My adverse grade won't matter, but I'll leave that as is as well. And we'll hit OK. And with that, I'll hand it back to Erin for a proper introduction, and this will take a couple minutes to run.
Okay, guys, sorry, but this is the first time I think we've kind of skipped a proper intro and gone straight into the software, but what's solving on Matt's computer is going to take about 4 minutes. And instead of just trying to fill 4 minutes of airtime, you're like, let's just put the intro afterwards. So kind of going back to the plan for our webinar today, as I mentioned, we're tackling 2 examples. The first of which is that access road project that Matt's got running now on the screen, and we'll come back to. So that access road could literally be any type of greenfield road. For our forestry clients that are here in today's webinar, obviously that's very applicable to you. This also could be applied workflow-wise to wind farms, even some rural county roads, especially if they're greenfield, mining access roads outside of the pit. Yeah, gas pipeline corridors, you name it, any piece of greenfield linear infrastructure, the workflow that we're showing in the sort of first half of the webinar, very much applicable. Second half of the webinar, as I mentioned, we're going to get a lot more complicated, and we're going to show you some really cool modeling cross-section tools and such that we've got for handling complicated in-pit haul roads. So for that first access road, kind of our plan for what we're going to do with it, obviously, we just went through that process inside of RoadEng's terrain module of creating our 3D model. This can be done using any type of topographic data, but of course, in order to do a proper, better analysis of where to put those preliminary road locations, larger resolution data sets obviously work better. So we're talking about a LiDAR, high resolution DEM data. We work with geotiffs, but you also can use other traditional survey methods if you would like. From there, Matt started this tool, and that's kind of what's running in the background now on his computer, which is, it's currently called Path Explorer. Name might change, but it's a great optimization tool that can allow you to find those preliminary road locations, kind of going from point A to point B. And the tool itself, as I said, it's all about the preliminary optimization. It helps you to, be able to identify where you should go to confirm to put your road, instead of, going out to the field, oh, where should I put my road? It now becomes a question of why should I not put my road here? The program itself is looking to minimize cost, obviously while meeting some constraints, which we'll talk about in a moment, but it's looking to minimize the earthworks and the surfacing costs, so your cut, your fill costs, as well as the surface area of the particular road. And it looks to meet your constraints. So as Matt showed you a moment ago, or if you're new to joining us, it's looking to minimize the grade, the side slopes, the minimum cut, max fill, and then there's some components that we didn't address, which is the idea of being able to set up a no-go zone or a high cost zone, or even the potential to take one of the streams here or all the streams here and assign a crossing cost to them. So if you do need to make a walk crossing for a stream or a larger body of water, you can assign a cost to that, and then the software is going to look to minimize that. So it's a really amazing tool for helping you determine where to put your road. I should also note it does use a simplified cross-section. So here we're looking at a road prism with some side slopes. We do not include things into the details like ditches, for example. They're outside of the scope of the preliminary tool. Yeah, and we can look at those when you kind of move into that next phase. So once we figure out where to put our road in the terrain module, we'll head over to locations. That's the other module of RoadEng. And this is where we can, very quickly convert that preliminary alignment into a much more detailed, full geometric road design. We've got some tools inside of here where we can further minimize the earthworks for the road project. And with a few clicks of a button, you can actually generate output sheets. Obviously, you can spend a lot of time customizing those too, but output sheet generation is actually a pretty plug and play templated experience. Okay, so that was the first project. After that, we get into the busy fun one, which I think looks really pretty. So here we're going to focus on an in-pit haul road example. We're going to create a template that includes some more interesting components, like having a berm included in certain conditions, as well as benching. You can we're going to have to manually create. We can't use optimization tools because of the constraints, but we're going to manually create our horizontal and vertical alignments and show you how you can have dynamic editing, calculate some quantities, and I think we'll finish it off with a drive through. But that's the plan. Hopefully, Matt, are you ready for me to share the screen back to you?
Pretty close, just a
Pretty
sec
close. Okay.
All right.
Sneak it. And while he's getting a screen up, yeah, I guess the webinar housekeeping. You're muted for the entire webinar, but we love questions, so you just have to type them. So if you'd like to engage with us at any time in the webinar, yeah, open your question section of your GoToWebinar panel, type in a question. You'll remain anonymous when we go to answer it. So with that, Matt, the
Cool.
screen is all yours.
All right, so yeah, and I did click one button when Aaron was speaking. So basically what I did when Aaron had the screen was it ran through it, told me that it found the 3 possible solutions that we're looking for, and now it's just post-processing those and turning them into, well, a proper line. So with that, we'll have, it's just finishing up thinking, but we'll have something proper momentarily, and then we'll jump over into, and there we are. We'll jump over into location. So just from that, we can take a look at what we have here. So it's looking at going from here to here. It's found 3 different routes, and we can jump over and do an actual design with this. So I'm going to just save this as topo. So this was done in terrain, and then we'll switch over to location to do a proper road design where we're looking at cross sections, volumes, etc. And we're just waiting for this to save. I'm going to open up location in the meantime. We are going to click new file. We're going to browse. And here I am going to choose what my initial alignment is going to consist of. So for this, I have my Path Explorer options generated. So I'm going to start with this guy here. Actually, I have something else currently selected, so I'll deselect that. So I'm going to use that as my initial alignment. I could go with multiple if I'd like, but I'm going to just start with the cheapest one.
There was a great question in the chat just asking, how do we know which was the best route from the Path Explorer options? So you'll notice here at the end of the XPath name that's currently shown on the screen, that is actually just like the rough cost that's being calculated. So when you go to look at the different Path Explorer options, looking at the name, the numbering, I should say, in the actual feature name will help to identify which is cost-wise the best route. I hope that answered your question.
And of those 3 options too, the options it picks are going to be within 10% of the cheapest solution that it found. So yeah, it's kind of, they're all going to be relatively decent solutions, and it may come down to a quality approach when you decide which one you'd like to pursue as well. Or you may want to look at several of them in more detail and location. All right, so we have a alignment. So that right now is following our cheapest solution up the hill. And right now, this is a bunch of vertices. So it's not really a proper alignment. We're going to convert this over to be a proper alignment using our polyline to alignment with curves tool. I'm going to allow it to, allow it to be up to 8 meters off the original. Favor something to get smoothed out a bit.
So just if you're new to seeing this tool in action, it's going to reduce all those points along the polyline into proper horizontal IPs with their curves applied. So Matt did define our minimum radius, and it's now just fitting it.
And the other nice thing is this isn't just a tool that you have to use with the Path Explorer output as well. So if you have a surveyed center line that you'd like to use, well, you could probably not surveying it as a proper alignment with curves. You can use this to fit it to that. If you have existing road line work as a shapefile or other vector format, you can use it for that as well. So it's pretty useful tool. And we'll let it go a little longer. Oh, go ahead.
Tackle another question, Matt, while we go here for a second?
Sure. Yeah.
Awesome. Okay, so it's a question that I mentioned, or at least a comment based on a comment I mentioned, which is we can't do optimization in our in-pit example due to constraints. It was just a question about what might those constraints be and why wouldn't it work?
All right, perfect. So I guess I'll set up the example that we're going to look with the haul road. When we run an optimization, we're looking to minimize the road costs through Earthworks. And for the in-pit example, where we're dealing with a pit ramp, we don't necessarily want to minimize our Earthworks. We want to more or less just work around the existing mine infrastructure and also set things up to develop the mine. So we're less concerned with minimizing the actual excavation involved because it's all going to get dug out of there. So in that case, we're going to manually choose the location where we put things.
But for this access road project where, yeah, we do want to minimize earthworks, we will, in the next few steps, start to show you how you can actually use that tool to reduce the cost.
Totally. All right, so the polyline to alignment tool is run. We can see we've got our alignment going up to the top with our curves being applied. And, well, we've used the Path Explorer tool. We might as well use our vertical optimization tool to take this the next step further and generating a vertical alignment that minimizes our earthworks as well. Now, with that, before we jump right into the vertical alignment optimization, we are going to want our cross-section to be set up to be appropriate. So we control our cross-section geometry by creating various options in our template editor. And basically our template editor, the templates are holders, and we have a bunch of components within them. So if we want to change our road from being a 6 meter wide road to an 8 meter wide road, we can just change the width, and it's basically a fillable form, and away we go. And I can do the same on the other side, or I can just delete that, copy, paste as right. Now in this case, I'm going to want to use the same template throughout, but we could also assign different templates along the length of our road if we'd like. So I just changed that width a little bit. We'll go over here. So instead of designing this and worrying about our grades by hand, we're going to go vertical options. We're going to tell this to sample in 20 meter intervals. I'm going to say what our minimum grades and maximum grades are. I'll set my K values. Now I'm happy with the value that we have set here. I'm going to add a control point at the start of our alignment. So here I don't want it to be the cheapest elevation for the cross section to go at the start, I want it to tie in with the existing ground. And another thing here I'll mention that we're doing this as an access road. It could really be something as simple as a machine trail too. So it's all kind of the same. It just depends on the standards that you want to follow. So if it was a machine trail, I'd go steeper with tighter curves, but this meets our needs. I'm going to hit process, set that.
So Matt kind of skipped over it there at the end, but Smart Curves is sort of a post-processing tool we can now add to a vertical optimization. So if you're already familiar with the software, what Smart Curves is going to do is it's actually going to look to reduce the number of overall curves, but just keeping the most significant ones. And that is the least technical way I can explain that. I don't know, Matt, if you wanted to add some more context, but
Well, yeah, it's just
a really useful tool for making sure the output of vertical optimization is a profile that you can actually construct instead of having curves that are back to back to back.
I made a mistake. So I typed something in without hitting the add edit button. So it came back as not feasible because, well, that alignment doesn't work with a 10% grade. Yeah, so we get to watch it think once more. Yeah, and Aaron's explanation is bang on. And I think at the bare bones, that function is it just removes insignificant curves and groups together curves that were very similar to be represented as a single curve. So just makes the end results a little more human without adding much cost to the solution that doesn't have smart curves applied. And there we are. So we've got our grade running up the hill. Now with this zoomed way out, it looks like, well, that's a lot of curves, but keep in mind, we've got about 4 kilometers of road here designed in a few minutes of clicking around and talking about it. And here we can see where that smart curves functionality is really shining, where we don't have a bunch of little curves in there. It's just a tangent because it's any curves in there would be very small without it. So we've ran our vertical optimization. We ran our Path Explorer tool. We can see over here, I've got my Earthworks being tallied for myself, and I can scroll down to the bottom to get a more detailed breakdown. So close to 16,000 cubic meters being excavated. We can see our costs over here. Now the costs and what's driving that optimization is driven by our ground types. So I've just told it that there's a single ground type along this road that costs 12 bucks a cubic meter to excavate, 4 bucks a cubic meter to place, shape, compact, turn it into a proper road. And then I've got my movement costs in here. So that's what's driving costs. The costing function is what drives the actual optimization. And that's that. So we've got the let's see, where do we want to add a pipe? That looks like a good spot right there. So if we want to put a pipe in here, so getting outside of the pure optimization side of things and just continuing with the design process, we can go to Culvert Editor, we can click Add, and we can drop that in. So we can see we've got our pipe added in. If we want to change the diameter, we can. So I'll go with the 600 and let's go 800 even. We'll zoom in a bit here just to see what we're dealing with. So we can see our pipe there. We can see our pipe in the cross section. If we want to control it, like adjust the skew or anything like that, we can. So I'm going to go Let's go 75 degrees instead. Pull this over a bit. There, we'll try 115. So we can move that around and see how our changes affect things in real time. So we could go through and we could add our remaining culverts anywhere that we'd like along the alignment. Once we're happy with what we've designed, we'll probably want to produce some kind of drawing package for it. So we'll go over to the multiplot editor. We'll set our page size to be whatever we'd like. I'll stick with 11 by 17 or ANCB. And I could add in individual subviews and build this out from scratch, but I'm not going to. I'm going to use our pre-set up web library with a bunch of templates on it. Now, with this, we can add in another chapter. And let's see here. So we've got that. Now I don't want to see these sections in 5-meter intervals. So I can go in here and I'll change it to, well, let's show every 20 meters. And we'll add in culvert points. And so we can see now we're getting every 20 meters, and the exception to that is, whoops, let's go 11. Yeah, and then this one, since we've got a culvert added in there, lands on something other than the 20-meter intervals. So that's producing a multiplot. If we'd like, we can, well, print it as you normally would, or we can hit File, Save As. We could save it out as a Venza file to keep the plan view portion of that to your reference. You can see where you're at as you either walk around and field truth the design before construction, or you can use it during construction to help locate yourself. And then if you're building this with some kind of survey control or with machine controls, we can hit File, Save As, and export it out as a land XML file. So that is a quick run through on an access road using the Optimal tools. Yeah, and I guess we can either dive right into the haul road, or we can tackle a few questions because it looks like a few have piled up there.
Yeah, why don't we, we'll tackle a couple of the questions that seem to be a little bit more related to this particular example.
Okay.
And then we'll save, the remainder and use it over inside of after the next example. Okay, this is a great question. Is polyline to alignment a new feature in RoadEng 11, or is it in previous versions?
Nope, it is totally a new feature and one that we're quite excited about. So it's, I don't know if we mentioned it in the start, but we are doing the demo in webinar in version 11, and version 11 we're just wrapping up the beta testing and finishing touches before we send that out in the world officially.
Yeah, and if you'd like to see a little bit more of what's coming in 11, I think in 2 weeks today, we're doing our version 11 preview webinar. So we're going to step through all the new functions and exciting stuff that's the byproduct of our R&D over the last year and a half or so, and what that looks like. So feel free to check it out. We'll include a link to it, to the registration page in the follow-up for this one. Okay. Matt, your next question here. Your stream locations are visible in Terrain 3D. Can they be portrayed in location through options?
Yeah, totally. Oops, let's zoom around here to get a better look at the hill. So in my 3D options, I've got my topo surface. So I've got the shading turned on. If I turn on display features here, we'll be able to see the contours and the streams in our 3D view. So there we are. Yeah, and of course we can see them in the plan view just based off of the background being displayed.
Okay, we're going to do one more question before we get into the in-pit example. With the optimization tool, will the optimization tool, so in this case I'm referring to Path Explorer, will it output a not possible option if the constraints can't be met without excessive cut and fill, or it will try and force a solution?
So it will tell you that it's not feasible. And I guess I'll just flash up the UI for it here again. So this tool is, it's also looking at Earthworks costs. So it's looking to minimize your cuts and fills based off of excavated volume. We've got our constraints like grade, radius, and then for feasibility and that excessive amount of fill, we put a limit on how deep we can cut at centerline or how deep we can fill at centerline. So that's this value here. And then another thing that just we'll mention on the fly, these values are the default values that we have here. But if we had a high cost zone, and a lot of the time, just based off using a simplified cross section, it's not required. But if we wanted to say, well, this steep bluff is, well, shallow bedrock. If we go through there, any excavation that we are going to do is probably going to be driven by our rock costs. We could say, well, that's going to be a high cost zone where we add in a, well, construction zone is the term we use for it. So if we said, well, we don't want to go there altogether, we could say no-go polygon. In this case, we could say, well, we can go there. We just want it to cost more. So we could say, well, our excavation costs through that section are probably going to be more in the vicinity of $50 a cubic meter. And we can put that in, and when we run Path Explorer with those construction zones or crossings, if it was a polyline, the software will consider that. So it's a pretty smart, robust tool. I probably went on a bit of a tangent there.
Let's head over into the sort of second example of our webinar today. So we're going to take a look now at a haul road, but one that is actually coming down into the pit.
Cool. All right, so this one is largely set up. We've already built our tin surface and started a location file. But our goal, and I guess I'll paint a little bit of a picture, tell a bit of a story. This rather large pit, well, we want to continue developing it. The plan is to, well, excavate where the existing pit ramp to the bottom is. And we're also going to want to set ourselves up to continue developing this pit out. So push the pit walls back as far as we can without actually taking down the rest of the wall itself. Now, in doing that, our pit, well, we're going to want some special cross-section considerations here that kind of deviate from that typical access road or even a surface haul road in a lot of cases. One, we've got so I'll open up the template editor here, and we've got something that's already somewhat set up. So one, my roadway, I don't want it to be my standard roadway. Actually using something similar to our urban cross-section for this. So it's just the urban with the sidewalk and gutters removed. And it's going to be quite wide. So 32 meters wide or 16 meters on either side. We've got a ditch, but the two things that are kind of separate this out from most roads is one, we want to include a safety berm. So we've got that berm added on the outside. And then 2, we want to have benches. So if I'm going to just pull this along here so we can see. See these benches relative. So the pit's been built with benches. We'd like to match that up, reduce our stability concerns, and continue that down as we go. And again, we don't want to push in and end up taking down the whole mountain. We want to match up that toe and continue down. So this slopes XVIII, so what is that, 18? And it comes from the library. And aside from just being benches, we have the flat benches name in there. So what this does is our road's going to go down on a certain grade, but we're going to keep the benches at a flat grade. So we're going to use this template. I'm going to actually get rid of the slope on the inside of things here to start. So we got our haul road, we'll hit OK. Nothing is applied, and that's because we need to assign that haul road cross section. So we'll go haul road, and we could assign it from a certain station to a certain station, but we're going to assign it to the whole thing. We'll click Add Edit. We'll hit OK. Now I'm going to take probably a few minutes of clicking around here. And this is where it's not just click a button and it figures it out for us like we did with the other. We're going to plan where we'd like to put this thing. So I'm going to use the existing bench that's here. I'm going to largely trace around that. And right now my road is just set on existing ground. I'm going to add in my horizontal curves. And we're not stuck with anything that we apply here. I'm just going to set my default's currently set at 60-meter radius. So I'm going to apply that to those remaining IPs to start. And then here, I'm going to plan to go from A to B. And for this, the pit's been built with a max grade of the existing ramp at 11, so I'm going to try to adhere to that. But as I said, we want to avoid stuff like that, where we're taking down way more than we'd like. So here's just the software being an easy to use dynamic tool. Well, we can move this around and we can make sure that we don't have our cut slopes screaming up the pit any higher than we'd like. So this is, to go back to that question that was asked, this is where we're not necessarily optimizing the ramp to minimize our cuts and fills, because we plan to take all of this. It's just all this other stuff that we'd like to avoid. And with this, we're going to have a nice surface that we can throw into machine controls. We can really get a feel for what we're dealing with. And let's pull this around. So again, these lines here are showing my slope stakes. I'm also looking at the 3D view. Pull these around, keep that away from the edge, pull this up this way a little bit. Everything's dynamic, so I can see the ground at center line updating as we move this around, and we'll keep pulling this. And we'll go a little larger for our diameter. And just to, I guess I mentioned it, and we'll see it again here, but we can see the road's going down and these benches are staying flat. We got our berm on the outside, and we'll continue.
And while Matt just does a little bit more dynamic editing of the alignment, I'm actually going to tackle, I'm going to call them easy questions. So for our audience, if you are wondering the machine specs that we recommend for RoadEng. So historically, we've recommended, really modest specs, kind of 8 gigs of RAM, standard business laptop. As we look at Path Explorer, which was the question here that I'm addressing, we are recommending slightly higher specifications. So Path Explorer is going to look to use, a relatively large amount of memory. So the more you have, the larger problems you can solve. So kind of our, minimum specs that we'd recommend if you're wanting to leverage Path Explorer, we're looking at 16 gigs of RAM and a slightly newer chip, an Intel Core i5 8th generation, for example. If we were to tell you what our, recommended specs are, we'd probably, increase that to like an Intel Core i5 10th generation with 16 gigs of RAM. So that's sort of our, recommended specs. That being said, you can absolutely still use a standard business grade laptop, a little bit less than that. It will still solve problems, just not of the same scale. And there might have to be some, making it A to B to C kind of things as you look to solve your problems. Okay, Matt's still plugging away. I'm going to answer one more.
You can answer one more.
Okay, perfect. Well, the last one's easy. It's just following up to ask what version we're running in. So just in case they didn't mention it, this is version 11. It's in beta. Full release is coming out within the next month. So, okay.
Cool.
Hopefully I took the pressure off so you don't feel like you can't make any mistakes right now, Matt.
Well, we're pretty close to wrapped up. We'll make this a little bigger. Get rid of that.
Nothing like designing a complicated in-pit haul road in 10 minutes.
Yeah, no, I think we're pretty well there. I've got the runway. Oh, I guess that's the joys of it being dynamic as we steepen things up and make that shorter by moving things in. There's a few little odds and ends that we'll capture out here, but with that we are there. We've got our runaway cuts taken care of. So yeah, we have a feel for what we'd like there. Now, one thing that I did was as we designed, I left the inside off here. I'm going to add that in, and this will be an excuse to see how the E library works. So I want to bring in some slopes. So I'll just go with this standard slope copy. I'm going to add that on the right side, so pasting it onto the right side. And here I'm going to tell it that I want my cut slope. I'm going to set it at 10%. So kind of similar to a daylight. I'm going to keep it coming in. So while anything that is going on, any drainage, surface drainage is going to be redirected back towards the berm, and we can manage that as we'd like. Fill slope, I'm going to set this to be 80%. And we'll hit OK. And since that template's already applied, it's going to be applied throughout. So there we are. And just a little tweak. We've got that little funniness happening here in the 3D view. We can use our graded functionality to help iron out those edges. So the rest is the same. It's we can take it over to multiplot if we want a drawing. We can export it to land XML if we want a surface for survey control or machine controls. And just while this syncs, I'll momentarily flash up one more option using a template that we're working on, and that is doing even more of the actual pit design right in location, where instead of going out, we'll account for the excavation below our road that we'd like. So if we go over to this guy here, I'm going to turn that other surface off. So similar design. I'm going to make it so we don't have to look through a surface to see what's happening there. But here, we're going right down to where we have a reference feature set up. So what that looks like in the section view, we're doing our actual pit excavation as part of our road from up here and working around. And then, yeah, something haven't shown yet, but let's jump into it. We've, of course, actually want to make this bigger before I do that. We can use our drive-through mode to really see what that looks like from a driver's perspective. So with that, we've got our haul road tackled in a few minutes. We've got our access road tackled in a few minutes. Neither workflow is really exclusive to either application. It's a pretty broad set of tools that can be applied in a wide variety of industries and project types. So with that.
Okay. Webinar audience, this is your chance. Type those questions in. We've got a few minutes to answer them. So Matt, your first two questions, are going back to Path Explorer. So inside the terrain model, perhaps we could, talk a little bit more about streams crossing costs. So one of the questions is, can you set stream crossing angles in the parameters for Pathfinder, which is Path Explorer, but that's totally cool. We're actually going to probably change the name so it doesn't sound so much like a car. Can they be crossing perpendicular or at an angle?
Not directly. Now, there's a few things that I'll walk back with that, not directly. One, when I ran Path Explorer here, I didn't even include my streams in the optimization. Now, once you do that, it's going to want to favor perpendicular crossings just because it's the cheaper solution. So it'll nudge it towards that without being an explicit constraint. If you have a major crossing that you actually want to control in a fair bit of detail, let's look at one of these here. Let's take this. So if it was something like, well, I want to go from here to here, cross this stream at this location in that direction, well, you could handle that. And it's a matter of just splitting the problem up and controlling your approach direction. So let's tile these side by side. Otherwise, I'm going to get confused. But if you wanted to go from here to here and set yourself up to cross in that direction, well, you could run it. So this being start to end -0. So start to end -0. We could say, well, where I start, I want to allow that to go to any direction. But at the end, I only want to control it so it comes in from the north. So that's going to make it so it comes in from this direction, setting yourself up. And then you can run another instance of Path Explorer, but controlling the start direction, so you're pointed in that direction as well. So it's not quite the same as just saying I want to control my approach direction. If there's something critical that you want to make sure it crosses here at a certain angle, then you can do it by splitting up the problem and using the I guess same term I was using, approach direction constraints. Hopefully that answers the question.
Okay, our next question. And it's a long one, so I'm gonna, do my best to consolidate it down. So obviously the purpose in Path Explorer is to look for the least cost to determine the route option, but what if you need to account for the construction of, say, a box culvert or a bridge? Can you accommodate both of those different cost types into the model?
All right, so I think so, and I think that previous question kind of well, partly answers the question. A lot of the time, if it's a major structure, it's not going to be, oh, just cross it anywhere. It'll be, I want to cross it at this location. So if you want to control that location, so it sets you up well to build that structure, then absolutely. Using the kind of the A to B, B to C approach and directions. Now, if it's something like, well, this stream over here is going to cost more than this stream over here, you can split those up and have different costs for different features. So if I want this to be a $1,000 crossing, and I want this to be a $5,000 crossing, and actually just for the sake of splitting it up a little further, this is going to be a $2,000 crossing, and this is going to be a $5,000 crossing. You can go through, sort them however you'd like, and when we add in our construction zones, we can say, well, I'm going to add a construction zone for my $2,000 crossings. So polyline, I want my 5,000, yeah, we'll go 5,000 for this one, and we can add that in. So it's not necessarily the same as this is going to be a box culvert, that's going to be a concrete slab on inverted T's. It's not really looking at that. It is looking at Earthworks costs primarily, and then we can add other costs for our crossing costs. So you still want to be aware of kind of, your actual crossing requirements yourself. But if you know those crossing requirements or even have a rough idea, just an order of magnitudes idea, you can add those costs in so it accounts for it when it's choosing its route.
Okay, the next question. So this was going back to that stream angle one, I think. So you've broken up your problem into a couple pieces. How do you put them back together to move on to location design?
All right, so the, it would just be a matter of, and I'll split something up here. So if we ran this as two different Path Explorer runs, I'll just right click, modify, close, whoops, wrong button. Right click, modify, join, and now we've got a single feature of that we can feed into location. Well, thanks everyone for attending, and thanks for those of you that asked questions for asking questions, and everyone else.
Okay, see you everyone. And we'll see you at our next webinar, which is, version 11 feature preview. We are going to talk about a whole bunch of super awesome, fun new stuff that's coming, including the full hydrology toolkit, more details on Path Explorer, whose name might change to something that doesn't sound like a car, and a bunch of stuff inside a location regarding multi-plot, grading, corridor services and grading, lots of really awesome stuff coming. So hopefully you can join us and have a wonderful rest of your day. See you, everybody.
Thanks, everyone.